Hello there, I'm Mike.
And I'm Lars.
So here we're here to tell you that domain-specific languages might play a significant role in your next architecture design. And we'll start off with a bunch of real-world examples from projects that Lars and I have personally worked on. So this is from the Equals project, which is about quality assurance and social pedagogy. So when you do QA in social pedagogy, you ask lots of questions that are part of standardized questionnaires. And here's a page from one of those questionnaires, and you can see there's sort of two questions at the bottom, which you answer on a scale. And you can imagine that these questionnaires contain lots of recurring elements, such as multiple choice questions or free text questions or these scale questions that that you see here. And also these questionnaires have some rudimentary control flow. So depending on the answer to one question, you might go down a different path depending on what you answered. And there's lots of these questionnaires. So on this slide, this is the overview slide. This is the overview page of all the questionnaires, and each button leads to a separate whole new questionnaire. So what we did is we distilled all the common elements of question types and control flow in questionnaires into a language that we integrated in the closure language that the whole application is written in. And here's just a small code sample from that language. We're not interested in the details of that particular language, just to show you that it's an actual piece of code that's written in that domain-specific language.
And moving on to another example, which is in the automotive domain. The idea here is that nowadays, if you buy a car, you don't just buy a particular model of a particular brand, but instead you're buying a high-tech device that has many hundreds of configurations options. For example, there might be a car manufacturer that offers you to buy the same model with electric propulsion and another one with diesel or other kinds of fuel, maybe gas, for example. And this car maker had a configuration model in place already, which was sort of like Boolean combinations of flags, where you could then compute, for example, this particular control device needs to have this bit set if and only if it has four wheels, four-wheel drive, and AC or something like that. So there's all sorts of complicated configuration options that you could design there, but it was not enough, and also it was based on a very ad hoc syntax in a custom IDE. So our project there was to provide them with a kind of a real programming language, or something that resembles much more of programming language, where you had scoping, so you could have nested keys. Here you have an example on the slide where you could say a dot y, for example. So y is a parameter of that scope A, and also instead of just having true and false, you could have numbers, you could have strings, you could have actual arithmetic comparisons, and so on. And on top of that, as an additional goodie, we built a type system for them that also supports things like enumerations. So, for example, the country code of your car may be a 2-character string, DE or UK or FR or something like that. And then you can, for example, have a condition that says, well, the heads-up display should display an arrow towards Mecca if and only if the car has been sold in some Arab countries. So these are the kinds of conditions that you could express. And obviously, we were interested in evaluating those conditions, so we built a compiler to Java bytecode using the ASM library. But using the same syntax, we could also do some rudimentary satisfiability checking. For example, if you walk into a car dealership and ask for a car that has 4 doors and 5 doors, obviously there's going to be a problem. So you cannot manufacture both 4 and 5 doors simultaneously. So there must be some mechanism to tell the customer that something is wrong, or even the rule author that some rules as written down don't make sense. And we were quite happy with how that turned out, and we could even go as far as having auto-completion and syntax highlighting on these things.
So here's another application from the automotive domain. AutoZar is an infrastructure and a DSL for describing the configuration of embedded computers in a car. And you can see here it's written in XML, and it looks kind of cumbersome and difficult to deal with, and it is. And we had a customer that had lots of tabular data in Excel sheets that they wanted to import into AutoZAR without having to retype it all. So they wanted a tool from us that would allow them to describe the tabular data, because it was not just one table, and they needed to design new tables in the future. So they wanted to be able to describe arbitrary tabular data and describe the relationship to the AutoZAR model, and then from that automatically create a bulk importer that would import that data into an AutoZAR model. And for that, we designed a domain model for tabular data. So it starts with a single cell, which is kind of the simplest Excel spreadsheet that you can imagine. You can assemble these cells into sort of records where you have different columns representing, different things. And then typically you have lists of these records. You can also even have, two-dimensional things where you have lists then also going in the horizontal direction. So you get kind of a nice little domain model for tables. And we then let our customer express that domain model as part of a domain-specific language, of which you can see a sample here. So you describe some coordinates that are kind of anchors for things in your Excel sheet. You can see here that there's references to subtables, and so on. So you can have quite elaborate structure and still be able to easily access the data in that spreadsheet table.
Right. Next example is a semantic web application. So I'm not sure who here in the audience is old enough to remember the semantic web. Mike, yes, me too. So the idea was here to build a kind of personal data management application. So as you know, you have personal data littered across the web. You have your personal data in Facebook, you have it on Twitter, Google, but also some more pedestrian things like your bank, and the postal service and so on. So each of those companies have some bits and pieces of your personal data. And the crucial thing here is that they control those aspects of your personal data, but you don't. So the idea in this project was to pull those data sources and then kind of put them together in a big semantic graph that's controlled by yourself. So it's residing on your own personal device, and it can convert the data from those different sources into this RDF format. And then you can make queries. For example, you can ask questions like, where do I post stuff on Instagram? So is it maybe only if I'm on vacation? So you can answer those questions if you correlate your GPS location that you maybe pull from your fitness tracker or something like that. And then you can kind of see that, oh, if I'm at home, I don't tend to post on Instagram, but if I'm somewhere else, I tend to post on Instagram. So that's just, of course, a very synthetic example, but these are the kinds of queries that you can send. And obviously, no person wants to write those queries, because not every person is a programmer who's interested in that kind of things. So the idea was to ship this as a mobile app that has some form of predefined a kind of insights built into it, and then you can just open up these insights and it will crunch the data for you and show it to you. And those plugins that are running in this app were built in JavaScript, because obviously for querying RDF there's already Sparkle, but Sparkle is kind of like SQL in that it gives you like some kind of structured data result, but it does not present it. And we thought that, well, for presentation, we could either make up our own DSL, or we could reuse one of the most popular presentation DSLs out there, which is HTML, combined with CSS and JavaScript, of course. And the key thing that we implement there is that all of the JavaScript code was executed in a sandbox that was even stronger than a browser sandbox, because we wanted to avoid things like plugins pulling data from your local storage that is already in the RDF graph and then sending it somewhere else, because that might be a violation of information flow. So instead, we implemented some kind of dynamic checks where a plugin was allowed to first fetch data from somewhere else, then put it into your graph, and then run queries on it, because then you are not at risk of leaking information. So that was kind of a combination of static permission checks plus dynamic tracing of those information flows. And there's also an example on the next slide of what it looked like. So that was just pure JavaScript code. I know there's a lot going on in the slide, but if you look at the first line, you see there's a pod.out, which is the thing where you can call out to the outer world, and you can do a fetch request as is usual in JavaScript, and then you do some processing here. This is some code that imports tweets from Twitter, and then it converts it into this RDF model, and then you use pod.in in the last instruction to actually put it into your semantic graph, and this is allowed. But if you would switch this around, if you would first manipulate the graph and then send something out, then the plugin would have to ask for your permission to do that.
All right. So here's a piece of surface analysis equipment. So where you see the red dot in the middle, you can place a sample, typically a semiconductor, where you want to analyze the surface at sort of the atomic level. So you can shoot like X-rays or electron rays at it, or you can run a little sensor across the surface that would provide sensor data. And the processes that you would run on a single sample can get quite complicated and can run for a long time, because you might want to scan, multiple places along the surface at different intensities and so on, and they might be different for each sample. So we designed a domain-specific language for describing those processes, and because that DSL was meant for end users of the hardware, we designed a graphical surface notation for that DSL that you can see here. So up in the where you see plan is the actual program that is supposed to run, has various constructs, also has control flow and loops and things like that. And moreover, the program kind of evolves as it runs, so it gets smaller and smaller and smaller, because it might happen that there are problems during the execution flow of the program, because the equipment breaks down a little bit, or something is slightly out of place, and at that point you might want to interrupt your program, store the intermediate state, and then run it again at a later point in time. And the nice thing about it is that at any point in time, what remains of the program execution is still a valid program, but it has a different execution model from, let's say, your regular programming language such as Java.
All right, so Mike and me have given you a bunch of examples now, and you may ask yourself, well, this sounds quite sophisticated and quite niche domains, but the truth of the matter is that you are already using DSLs, and they may not be graphical like Mike just described, but there's a whole lot of these languages that you're using already. So I already mentioned HTML and CSS, for example, as domain-specific language, but there's also SQL, and I'm sure almost everyone in the audience will have written some SQL code before. If you're working with any kind of cloud infrastructure, then you may be writing YAML on a daily basis. Not sure if you like it, but it is a domain-specific language for that purpose. Of course, Mike had to put Emacs Lisp on that slide because he's a big fan of Emacs. And to be fair, not all of those languages are kind of similar. So there's quite a whole different range of their expressive power and how they're being defined. Some of them are more ad hoc, like LaTeX. Some of them are less ad hoc, like SQL. If you've ever had a lecture on database implementation, you will know that SQL is based on relational algebra. So there's actually a mathematical foundation behind that concept. But anyway, the point of the slide is to tell you that DSLs come in all sorts of sizes and shapes, and they are ubiquitous, so we use them all the time. Yeah. And at this point, I think we should answer the question, like, where do now custom DSLs fit? So we've given you a bunch of examples on custom DSLs that we build. We've also given you examples of DSLs that you're already using. And it might be a bit tricky to decide if you're dealing with a particular software domain. Should I put a DSL in there, and where does it fit? So in our opinion, DSLs may be useful if you have a complex user-defined flows. So anything where it kind of feels like the user is supposed to program to a small extent, maybe. And if the user wants to program, then of course we shouldn't give them our normal regular programming language. But to circle back to one of the examples I gave you earlier on this car configuration model, the initial idea that the car maker had was to write those rules in normal Java code and then only allow a certain restricted subset of Java things. For example, allow if then else, but do not allow while. So you would have to write some kind of extra compiler that runs before the normal Java compiler to figure out if something is not in the fragment of the DSL that's supported. So in that case, Java, the language, was too flexible for analyzability, so we decided on going down the DSL route. Or alternatively, if the language is not expressive enough to achieve readability, and we will see some examples of how that will look like. in the remainder of the presentation. Those two things, too flexible and not flexible enough, they kind of seem contradictory, but there's actually like a very well-defined set how that works out in the end. And finally, DSLs may also be useful in situations where there are common domain rules that need to be understood across components. So we specifically don't say across different jobs, because in the past, many times it has been tried that, for example, business people are writing code in some way, low code, no code, whatever it's called these days. We're specifically not going on about that. We're just saying here that DSL may be useful if you have a ubiquitous language across your business domain, and then multiple different engineering teams need to understand just how those rules have to be interpreted.
So at this point, hopefully we've convinced you that you might think about designing and implementing a DSL in your project. Unfortunately, there's some bad news because domain-specific languages are essentially programming languages. And so if you go the route of implementing your whole new, great, completely original language as your DSL in your project, well, there's a lot of things that you need to do. So you need to think about syntax. Well, you first need to think about what the syntax looks like, but you also need to think about analyzing that syntax, about things like lexing and parsing. You might have to think about representing your program as an abstract syntax tree. You have to think about semantics. You have to think about how to compile or interpret your DSL. So you might have to write a compiler. You might have to integrate that code. Well, you probably have to integrate that code with the rest of your application. And also, if it's your whole new language, then people are going to expect some standard and recurring functionality from it. So you might have to write a standard library. So all of the things that people have already done for you implementing a programming language, you're then going to have to do it yourself if you're doing your whole new language.
Yeah. So this sounds daunting, right? Now, presumably, many here that are listening to this talk are to some extent familiar with Java and the Java ecosystem. And there's this great tool that's called Xtext. And we haven't mentioned Xtext yet, but in fact, two of the examples that we showed you initially were built on top of Xtext. So that was the card configuration and I think the autosolve run, right, Mike?
Yeah.
Yeah, so those were both based on Xtext. And in case you haven't heard about it, it's a stack of tools. Some of them are directly from Eclipse. Some of them are like third-party tools that they pulled in. But generally speaking, it's in Eclipse framework. And Xtext is supposed to take care of a lot of the hard parts. So basically what Mike just described. For example, for lexing and parsing, it differs back to ANTL-R, which is a Java framework, or it's a Java parser generator framework, which you can use outside of Xtext, but Xtext like integrates this nicely. So you have a DSL inside Xtext to write your grammar, and then Xtext parses that grammar and produces some parser from it. Also, you get an AST, which is based on Eclipse modeling framework. Now, I certainly did not know what EMF was. I had to buy a book on that. Apparently, it's some kind of ancient technology that somehow relate to models and meta models of things. But anyway, you also get from this grammar, you get this AST, which is also code generated. So you get Java code generated for that. And then you can also do your regular AST traversals and so on. And if you're willing to go to a great extent, you can also get IDE support via the language server protocol. I'm not up to date on the latest and greatest there, but I think there were some working demos how you can get it into VS Code and maybe even into those online VS Code variants. So it's supposedly quite powerful that you can just like write down a single grammar file and then get everything based on that. So that's the batteries included idea. So
that sounds too good to be true, Lars.
Yeah, there are some downsides, unfortunately. If you look at all the Xtext and EMF tutorials, they tell you open up Eclipse and then click on something. So I'm like, I don't want to click on things. I just I like text, right? I like to put text in my source control. So please let me write down the text, and then yeah. It's possible to automate that, for example, to put it into Gradle, but it's definitely not easy. However, naming, scoping, syntax lighting, and all of these things are already taken care of. So many programming languages do not get scoping right. So it's a breath of fresh air that Xtext actually gets that right. Yeah, but as I mentioned, this customization things is quite hard. For example, Xtext assumes that whatever you're writing in your grammar has a one-to-one mapping to your AST. However, that does not reflect how modern compilers work. So typically you have many intermediate ASTs and you have multiple syntactic constructs that map to the same AST construct, or maybe the other way around. You have, depending on the context, something is either this AST or that other AST construct. So customizing that and maybe even putting the AST itself into text is also hard. So I'm not sure who here has heard of Xcore, Xbase, eCore, and all of these things. So these are all apparently some ancient Eclipse technologies that you can put together in just the right way, but it's quite hard. And this leads me to yet another proof of the there's no free lunch theorem. So we get a lot of things for free, but we have to work hard at other points. And also, unless you want to write a DSL that compiles specifically to Java, you still have to write an interpreter or compiler. So yeah, I still like what we built with Xtext, but I think Mike has another opinion on that.
Well, also writing an ANTLR grammar is not as easy as you made it out to be, in my experience. And in a former life, I published on parsing. So, so there's an easier path, as Lars mentioned, to this, because often you don't. Well, I mean, you shouldn't want to do your whole new language in most situations. Often, what you want is you just want a single feature in your existing language. So, for example, here's a feature in the Haskell programming language called list comprehensions. So the first equation just says, well, I want triples, all possible triples of numbers from 1 to 10. So you just write, I want all triples A, B, C, where C comes from 1 to 10, B comes from 1 to 10, and A comes from 1 to 10. And there's another variation of that same idea where you just assemble all those triples that constitute the side lengths of right triangles. With that constraint at the bottom that just says the Pythagoras theorem essentially. So I mean, I like Haskell, but I also like programming in Racket, for example, which does not have list comprehensions in its core language. And so if I really like them in Haskell, but I want to use them in Racket, fortunately, I can import them as a library. Now, the surface syntax looks quite different because Racket syntax is based on parentheses and not indentation, but hopefully you can see that the idea is pretty much the same. So these two vertical bars introduce the list comprehension syntax. And then, well, again, you have C, B, and A being numbers from 1 to 10. And you assemble lists, which are the triples of Racket of A, B, and C. And similarly, you have that constraint on the lengths of the right triangles here. So the structure is exactly the same as in Haskell. So not only can you do this as a library, but also implementing that library in Racket is not so hard. So you just write a macro, and this is the entire implementation of the Haskell list comprehension syntax. Again, we're not really interested in code details, but this is really the whole thing. So macros are quite a powerful tool that give you, individual syntactic elements, and if you have enough of them, they might constitute a whole language. But if you just need one, well, you just define one macro. What you also want sometimes is you want your existing language, but you want it sort of interpreted in a different way. So the code that you see here is standard Racket code. So you can see or and define all of these things, and let and if are all standard elements from Racket. But if you look closely, you can see that this program describes a probabilistic scenario. So one of these classic scenarios where you're wondering whether it rained based on your observation of whether the grass is wet or not. And you see these calls in the middle where it says flip. Those represent a coin flip, where a certain probability heads comes up or tails comes up. And so this describes a probabilistic scenario. But when we do this, when we run this program, we're not really interested in, did it rain or not? We're interested in the probability on whether it rained or not. And for doing that, we need to either perform probabilistic inference, or we need to run the program multiple times in order to create samples over which to integrate in order to get those probabilities. So we need a different execution model for the same existing code. And this is also something that Racket lets you do via something that's called control abstraction. And this is something that quite a few languages give you. Sometimes it takes a slightly different form. So quite a few languages offer you syntax for something called monads. In this case, this is again Haskell, where you can write the do keyword and it gives you a special monadic syntax where you can customize the execution model, among other things that you can do with monads. But hopefully you can see the idea here is the structure of the program here is exactly the same. And again, you can implement the monad in such a way that it will perform a probabilistic sampling. So, these things are what we call embedded DSLs. So they're just, small languages that become part of larger languages that already exist. And these larger languages are called host languages. And the neat thing about embedded DSLs is that we don't have to re-implement all the things that are already there. Embedded DSLs work particularly well in some languages that have a certain set of features that make them very flexible. So you saw earlier that I implemented a macro, added a new syntactic element to the language. And the Racket language really has world-class macro support. Generally, Lisps, such as Clojure, have good macro support, but also other languages such as Elixir have that, and more. I think a lot of languages are thinking about adding them. Monads are great for abstracting over control flow, and Haskell and Scala and F# and Kotlin, for example, have special monadic notation. I mentioned this control abstraction thing. That's quite an obscure thing, but I think if you've heard about Project Loom in Java, this is also about control abstraction. So maybe in the future we can add Java to this list here. But Racket and OCaml, for example, have that. And also, if you have flexible overloading, that helps you create the semblance of designing your own syntax, even though it's really embedded in the syntax of your host language. And Haskell and Scala and Kotlin are notable examples that let you do this. So when you're doing DSL design and implementation, really there are different paths to take, and you don't have to start by doing your own full-on DSL. So you can really just start with an embedded DSL. You can start very small by defining an individual macro or defining a new monad. You can put that in a library, experiment with it. There's also complementary to that. There's also some prototyping tools. So Redux might help you with the semantics. Auth is a tool that might help you with the type system if that's what you want to do. Lars already mentioned Xtext, which helps you with implementation tooling if you want to go beyond embedded DSLs to your full hosted DSL, and there's a couple more tools in that space. But I would still encourage you, even if you're doing your own full-on DSL, to use existing concepts, to reuse things from the languages that you already know and that exist, mainly because programming language design is hard, right? One of the reasons it's hard is that if you're designing your language and you have coworkers and customers, they'll want to have a word with you on what that language looks like. If you tell them, well, we're designing our own language, they want their own keywords, they want their own syntax, they want their own semantics. And Waller's law says typically that discussion is going to be most intense and is going to take most time in the aspects that aren't really the most important ones. So lexical syntax is great, and it might have some impact on the usability of your language, but semantics is much more important. But you're still going to have lots of arguments with your coworkers and customers over what that lexical syntax looks like. And moreover, if you're designing your full-on DSL, then you might start small, but almost any language, I mean, this goes for all software, right, that it grows over time, but it also goes with languages that inevitably, I think, or in most cases, you will find that your domain-specific language, which started out as this small, particular domain-specific thing, will evolve into a more general programming language. And so
You say evolve, I say escalate.
so that's that's I think what Phil Greenspun tried to say, right? He said, well, DSLs are great, essentially, but I think Phil was trying to make 2 points here, namely that any sufficiently large program will grow something, will escalate, some part of it will escalate into its own language, and that language will itself escalate into a poor bug-ridden version of an existing language. So you might as well just do it right from the beginning and choose something that's already existing to benefit from the work that's gone into that.
Yeah. So now, assuming that you're a software architect, you may not care about if your comments start with 2 minuses or 2 slashes or something else entirely. So let's now shift gears towards the big picture and look at how domain-specific languages are software architecture. And there's one slide here which I think may be read a bit controversially, but I do not intend it to be controversial at all. So if we look at GraphQL, which is kind of the new kid on the block how to write web applications. And if you compare it with the incumbent, which is REST, I would say, then you can easily see that GraphQL as a domain-specific language really changes the way that you have to design your web application. Now, again, I'm not trying to say which one is better or which one is worse. I'm just saying it changes your software architecture. And I think this is the best argument that we can make, that if DSLs change your software architecture, then they are software architecture, right? So if you look at the more traditional model of one slide back, please. Sorry, I wasn't done yet.
Sorry.
Yeah, in the olden REST model, what you do is you have resources on the server, and you exhibit those resources with some fixed semantics. For example, you have get, which is read only. You have put, which is idempotent, and so on. You have safe methods, unsafe methods, and all of that is kind of fixed. It's described in the REST model. So you have a lot of logic on the server side, and the client basically doesn't have to do much except of keeping track of some URLs, maybe. If you choose to use the GraphQL model, if you choose to use it as a DSL, then you exhibit something like a query language. So I put the SQL in here, although they're not really that similar. But the idea is that you have a domain-specific language where you can specify what parts of your data you want to get, what parts of the data you want to update, and then much logic of what you do to the data is residing on the client side, and the server side needs to translate that, what it gets, into whatever it's using as a database. So I think that's quite obvious that there's a big distinction here. Now, next slide. Yeah. So why do DSLs have to do something with architecture? Well, in our opinion, domain-specific languages are first and foremost a tool to manage complexity. And we see or we feel that domain-specific languages are extremely useful together with domain-driven design for the very simple reason that they start with the same word, right? So it's both something about your business domain, and you can express rules about how your domain works inside this language. And fundamentally, designing a domain-specific language empowers your users. And note that users doesn't have to mean your end users who are opening up your app and doing something with it. It can also mean internal users who are there to customize whatever your application is doing. So those can be people with a lot of knowledge about the domain, but maybe not at all knowledge about Java or Racket or whatever, but you give them the tools in order to do things. We've had a project recently, I cannot disclose much of it, unfortunately, where the engineering team designed kind of a DSL for a particular team in their bigger corporation, and they even designed a debugging tool for that team, because those business rules are so complicated that it's not obvious that they work correctly for the end user. So they even gave them a debugger with stepping through things, and I found that to be quite impressive. So it empowers the users to do whatever they can do best. And also, if you're talking about quality goals in software architecture, then our understanding is that domain-specific languages form the foundation for adaptability and modifiability.
So still, I would like to put in a word of caution here. Really, if you want to put in a DSL in your software, it is a major decision, and you should approach it carefully. So here's a code sample from an existing DSL that we found in one of our other projects, and this is a DSL that we did not design, but implemented because there were already 6 million lines of code in that DSL. This is about automation control, about control automation in a semiconductor factory. And well, the way it works is that something happens in a piece of equipment, and it triggers something. It triggers a piece of code. And the thing is, the way it works, it always triggers the same piece of code, even though the equipment goes through different phases. And so the code needs to remember what phase the equipment is in. And you can see that there's a phase variable, global variable here, and there's a magic number that's assigned to it. So I mean, generally this DSL was just something that was made to look like BASIC, but that was not very well attuned to the domain at hand. And so the code here is really cumbersome. It's very difficult to debug and understand because you have to remember to document these phases and so on. So because there's 6 million lines of code, the mistakes in that DSL design just replicate, indefinitely, and it's very difficult to then replace the overall system just because you have these 6 million lines of code. Also, just doing a DSL might impact your building block structure because, well, there might be, some of your building blocks might be written in that DSL and might live in slightly different place from your regular code, and also your deployment procedure. If your regular deployment, deploys your regular system, but your user code again might live in a different place, so it might impact all your infrastructure that you have to do with CI. So, if you
source control management,
source control management. Yeah, I've certainly seen systems where sort of in fact, this very system, right, the implementation of the DSL is quite well managed in source control and runs through CI and so on, and it has tests available. But the DSL code lives in a completely different place at the customer side, and who knows what the current version is, right? So you have to think about those things, and again, that makes DSLs impactful in your architecture.
Yeah, and this is why both Mike and me have been working on a curriculum for domain-specific languages, and it's a work in progress. So caveat here, you cannot book this training as of yet. We're still working on finishing it, but you can peek at the GitHub page, and or you look through the contents of it, and we would be extremely grateful for your feedback on it, because we would like to hear from everyone how they feel about domain-specific languages, and we are also quite open to have debates on this topic, if it's actually software architecture or not. Of course, our opinion is it is software architecture, and we're happy to clear up any misunderstandings on that fact. Also, we would be interested to learn from you what are the kind of questions that you ask about, or what do you think DSL should solve, and how they should be designed. So we would be happy to incorporate that into our curriculum as well. And let's just,
Yeah, so and this will be hopefully, if it's approved, it will be part of the advanced certification program in iSAQB, we should mention.
Yeah. And yeah, now let's close off with a quote, I would say.
Yeah, from Bill Gosper, old quote actually. Well, I mean, you might already have a DSL even if you don't know about it in your program, because likely your software architecture has a domain model, and your software behaves differently depending on what's in that domain, what the data is in that domain model. And that makes your domain model already a programming language, just possibly a stupid one. Thank you for listening.
Thank you so much, Mike and Lars, for this insightful talk. Yeah, so let's jump to the first question. Can I do embedded DSLs in Java?
So I've done that, right? I remember doing that in a project, but the problem is that if we backtrack a little bit over sort of the things that make things good host languages, then Java currently at least basically has none of them. It has some overloading, but not in the way that's very useful for DSL design. I mean, you certainly have some abstraction facilities, and you can sort of try to twist the Java language syntax, try to twist that into what you want for your DSL, but likely you are not going to get, if your DSL is sufficiently different from Java, you're likely not going to get a convenient notation in your program. This problem might be alleviated a little bit with the introduction of control abstraction. People have not done a lot of experiments in that area, I think. But really, you're much better off doing it in one of those languages. Even if you end up, I remember the one project where I did a DSL that was based in Java, we did it in Racket first to do the design, and then we transferred that design over to Java.
I have a slightly different opinion than Mike on that topic. So if you're doing any kind of web programming in Java, you may have seen expression languages already. So I remember my first exposure to Java expression languages was when I was building stuff in JSF. Unfortunately, that one application that I built in JSF is still running, and I still have to maintain it. So that's a bit sad. But anyway, there are some ways to basically put if your DSL is small enough, you can just put the expressions into strings and then maybe put them into annotations or
But
something
that's
like that.
cheating, Lars.
It might, but
That's
I mean,
not
the
really.
question is, I mean, it is embedded in the language, so technically
Yeah,
it's an
well,
embedded DSL. But yeah, maybe this is not how you would define embedded DSLs. But I'm just saying, like, if your use case fits into such a purpose, then it might be overkill to use anything bigger than Java annotations with a bunch of strings. Of course, that has downsides as well. You have to make sure that you're checking these things as early as possible so that your program doesn't have a pass error somewhere at runtime, which would be a bit embarrassing. But anyway, so there's once more evidence that DSLs come in all forms and shapes.
Okay, thank you for your thoughts. The second question, it seems the host languages you list are all functional languages. Are only functional languages good for doing embedded DSLs?
Well, not quite, right? There's Kotlin on there. But admittedly, the things that make Kotlin appropriate for doing embedded DSLs are features that come from functional programming. So these facilities that you see here were mostly, except for overloading maybe, were mostly developed in the context of functional languages and have been there in place there since the last century. So I would say, in principle, that does not have to be true, because also object-oriented programming languages can have these facilities, but they're slow catching up with them. So my hope is that if within the next 10 years, we might see, we're seeing Java catching up by adopting control abstraction, which is also a concept that comes from functional programming. And of course, we're seeing lots of functional programming stuff generally get imported into object-oriented languages. And maybe one day we'll just see that, see enough of that be available to make it more practical in object-oriented languages. But also maybe by that time, we'll all see the light that functional languages are better for doing software architecture anyway. And then this whole problem will just go away.
Yeah, and depending on whether or not you define Rust as a functional programming language, probably not.
No.
Then Rust also has a quite powerful macro system. I don't even think we listed it on the slide, right? But Rust
Well, it has macros, right? But the restrictions in the type system, I think, make it not the ideal target.
Right,
host language
possibly.
for
But I mean,
DSLs.
technically, it does have some quite interesting things that you can do with the macros. And yeah, but basically, I can only emphasize whatever Mike said.
Okay, and we have a last question. As an architect, do I have to design the DSL myself?
That's yeah, I guess not necessarily. I mean, what you have to do as an architect is to have to identify where your DSL fits and what it's supposed to do. So you have to design its expressive power. For example, you would have to define what inputs it can read, where should it push its data, what kind of other systems does it affect. So your DSL make some control flow decisions, and everything else then kind of becomes microarchitecture. So if you're doing the lexical syntax with / or with --, then you probably don't have to care about that. But typically, since DSLs affect many different teams in your entire organization, this is what I also mentioned by having it being a ubiquitous language, then probably it's a collaborative effort between software architecture and the various engineering teams, and also the people who end up using it. So asking them probably won't hurt. But basically, it's not necessarily the case that as an architect you now have to frantically learn Xtext in order to understand how to write down your grammar. That, I think, is not, strictly speaking, necessary for the architects.
Okay, and I guess we have another question, or a hint. In our company, we have implemented our variant management with Prolog. We have also written a front-end tool for our internal customers to give them the possibility to customize their products easily and without a great complexity.
That's great. That sounds exactly
Prolog,
right.
Prolog is nice, yeah. Yeah, we have not mentioned Prolog here because its execution model is so different from all of the other programming languages out there. But I do like me some good Prolog.
Yeah, but of course, I mean, Prolog is essentially a DSL, right? So it's never sort of made it big in software development, but it's great as a DSL for many things. So I've also seen that used essentially as a DSL for crew management and airplane crew scheduling and things like that. But it's also an example of a DSL where you have an alternative execution model, and as such, of course, it can also be embedded into these other languages that support control abstraction.
There's a JavaScript. There's a JavaScript interpreter of Prolog. So if your application is JavaScript based, then go ahead.
No, but I think that generally the idea is brilliant, especially because I mean, the previous question is, do I have to design a DSL myself? And this is a case where somebody obviously just used an existing language, right? And that was kind of our point, that if there's already something in that space that you can borrow from, you should totally embrace that instead of doing your completely own thing. And I think, all kinds of issues here, right? Also, implementing Prolog efficiently is quite a lot of work. Other people have done it. You should benefit from that.
Great. Thank you very much for your answers, Lars and Mike, and for being with us. I hope you enjoy the rest of the day at SAQConf, and please, everybody, give feedback over Hopin, and take care and goodbye.
Thanks. Have a great conference.
Bye.
Thank you.